Hello, everyone, and welcome to today's ONOG webinar on simplifying hybrid multi-cloud networking with intelligent automation. My name is Michael Thomas Clark. I'm currently the chairperson of the ONOG DevOps Steering Committee and co-chair of the Hybrid Multi-Cloud Security Working Group at ONOG. Today's subject is one that is near and dear to me personally. I started my technology career in network engineering. That then became my springboard for launching first into data center management and subsequently into enterprise architecture before joining up with the cloud and DevOps revolutions. I will admit, an unabashed advocate both of expressing infrastructure as code and of automating IT operations wherever possible and practical. Before we get started in earnest today, just a quick bit of housekeeping. We will be taking questions throughout today's webinar. Simply enter any questions you may have in the Q&A section in the Zoom dashboard, and we'll look forward to addressing those at the end of the webinar. Also of note, today's webinar is being recorded and will be available on demand on the ONOG website's webinar archives at onog.net. With that, it's my great pleasure to introduce our guest for today's session. Joining us in the ONOG virtual media studio, we have Chris Wade, co-founder and CTO of Itential, and his associate, Rich Martin, senior technical marketing engineer at Itential.
Thanks, Michael.
Thanks for having us, Mike.
Thank you. So before we get into the meat of the program here, just a few thoughts. Today's subject is clearly an ambitious one, just as the title of our program suggests. It's also, I think, a sign of the times that while we are talking today about network management, your company, Chris, is not the kind that we would think of as a traditional old school networking company. Rather, it is very much, in my mind anyway, a modern network management concern. And by that, I mean one that is essentially a software company. Also, a sign of the times, it is one that is very much focused on network automation. Now, automation, of course, is a key concept these days, particularly in organizations that have adopted cloud-native architectures and DevOps practices. Whereas we know the goal is to achieve significantly higher degrees of efficiency and effectiveness in the delivery of value to the marketplace in the form of software. In this regard, I think it's fair to say that network management, much like security management before it, has been something of a DevOps outlier, with the responsibilities that have traditionally been the realm of those groups still typically sitting in different organizational silos. With that in mind, I'm guessing that perhaps a goodly number of our listeners, like many of the enterprise clients that I consult with, are still operating in that old school vein. So I'm wondering, is that also how you see things, Chris? And if so, am I correct in perceiving that Itential is really very much in the business of being a game changer in the network management space?
For sure. So, today's topic is really focused on multi-cloud concepts. And when we think about, kind of this destination of infrastructure as code, and we really think about kind of automating across multiple domains, we're really moving from a world, and those that we've talked to in the past understand we're moving from a world going from really a human-centric CLI kind of mindset to a machine-centric API mindset. And for those working in the cloud domain, this is kind of second nature. So when we think about how networking specifically is affected by this, we're really talking about how we're moving from a world of EMSs to a world of controllers, and it's really around kind of software abstractions of networks, and we really have to rethink how we manage networking in general. Things are quite different, and I think if we focus for today a little bit around some cloud concepts, when we think about public cloud regions, they're really orchestration layers on top of a variety of virtual networking concepts, whether it's a VPC or a VNet. And as we get into some of the demonstrations later on, we'll kind of show how we can automate those concepts independent. But really what we see customers going through, and you drew parallels to kind of security and other kind of parallel infrastructure management domains, is we're really thinking about how do we take people's existing networks that predominantly in the data center or at the edge in remote branches, and how do customers start to adopt more programmable, more software-centric networking concepts, and how do we onboard these? How do we operationalize these? How do we consume them? And how do we get the most value out of the investment in kind of next generation networking technologies? And we have to pair that up with some of the macro trends, which I'm going to talk about here in a minute. But what most people are challenged by is that we can solve some of these in isolation. And if we just restrict ourselves to cloud networking domains, we have a certain set of techniques, certain sets of technologies that are specific to solving those challenges. And then we have, SD-WAN and some of these other types of technologies in other portions of the network. And the ultimate question, I think, for operators of networks is the velocity of change is ever increasing. And the question is, how do we put sources of truth and platforms that can onboard these technologies and bring a holistic strategy so that we can serve our end customers, our application owners, our business owners, a standard network API so that they can take advantage of all these technologies that they're onboarding. So today we're going to talk a little bit about cloud, but we can see these same concepts kind of making their way into all varieties of kind of network technologies that we're onboarding. So something in ONUG that's near and dear to most people's hearts is the WAN is really transforming into SD-WAN. I mean, I think we have 60 different vendors participating, providing some sort of SD-WAN controller concepts. There's been a dominant theme around data centers moving to cloud concepts. Today, we're going to talk about going from public cloud dominated by a single cloud to a thought of multi-cloud, and we'll introduce the concept of distributed cloud. Security's innovating to zero trust. There's a whole concept around consuming security services rather than deploying virtual functions yourself. And then this concept of living not in the public cloud, but in the centralized public cloud. And then as that moves to the edge, how do those innovations affect us? And as we're looking at adopting these technologies, the rapid progression of these technologies drives the need to say, how can we onboard and accelerate the velocity of changes in the network so that the business can kind of move at the speed of technology that they require. So we were talking a bit before about the concept of, most enterprises, maybe not most, but a lot of enterprises historically dominated by a single cloud theory. And before we even get into the edge cloud and distributed clouds and SD-WAN, we really wanted to spend a minute just on some research around how many clouds does the typical enterprise have. So Michael, I don't know if you have any comments from your discussions with the people you consult and the market that you observe on kind of where we're at in the progression towards a multi-hybrid cloud environment.
Well, I think the 81% number is somewhat astonishing, right? I mean, it does line up with what I'm seeing. It's just a big number, and it's a big number that's come at us pretty quickly. If you were to compare that to 3, 4, 5 years ago, just a little bit of an anecdote. My first experience in hybrid multi-cloud environment was probably a decade ago, when one of my consulting partners and I had a client that was doing an ERP implementation. It absolutely required going to a cloud other than the main production cloud, which at the time was a very, very straightforward Azure. That's all Azure had about a decade ago. Sorry, Microsoft, but it wasn't that advanced, and so we needed an ERP platform, and so we were multi-cloud by definition. At the time, I thought that was just darned inconvenient, right? Because for obvious reasons, you had to manage that complexity. But more recently, you see people doing it not because they have to or don't have any other choice, but because they're making a strategic determination not to put all their eggs in one basket, the arguments, right? And yet, where I'm seeing this really happening is in larger enterprises, precisely because it does get really complicated, to state the terribly obvious, right? It gets really managing this complexity that goes with multi-cloud, paying for it as well for services that may overlap, may be redundant, maybe not, but it's a real it's a real big enterprise play at the moment. And so when I see clients that are, say, in the broad mid-range, maybe 1,000, 2,000 person company, they're really inclined to try to make sense of it with fewer providers. But I think increasingly that's getting harder to do. And we can talk about this later perhaps, but now with Kubernetes and containers, flexibility is another thing that's driving people's adoption. So there's a lot of factors at play.
For sure. And maybe one observation that I find super interesting is that, 5 years ago, there was a big push for cloud management platforms and the concept of abstracting and generifying, the variety of clouds that would be available to you. But obviously what these cloud providers are doing is they are trying to differentiate themselves every day. So the uniqueness and the variety and proprietary nature of the APIs that are available are really driven to comply with specific use cases. I think it's well known, how each cloud provider positions themselves and provides kind of unique differentiating value, which really drives different lines of business within the enterprise to say, hey, I want to put my workload in a specific location because they have optimized, not just infrastructure, but applications and services and platforms that help me. So, in the networking realm, Untitled especially is very focused on providing abstract and federated concepts across multi-domain networks so that you don't necessarily have to understand the intricate details between varieties of vendors. But we almost find the opposite to be true in some of the cloud opportunities where the differentiation is actually driving the adoption of different clouds. So one line of business might want to move into cloud A, and a different line of business might want to move into cloud B to optimize themselves. And obviously from an infrastructure and IT perspective, it's our responsibility to support the business and make sure that we're operating as efficiently as possible and connecting everybody with a high quality of service and in a secure environment. And the velocity of that change, appears to be ever increasing. And I'll touch a bit on some of the SaaS-based concepts that we think are accelerating this trend. But when we talk about network engineering and operations teams that are taking this on, we've talked a lot, and you even said at the onset, Michael, you were talking about kind of infrastructure as code in a broad term, and network infrastructure as code as a specific answer to some of these challenges. And we've done a lot in the past talking about CI/CD pipelines and principles and source of truth and putting source code or config into things like Git repos. This is really kind of table stakes on the cloud side, and not to let us off the hook, but it's easier to do that because we had less variety that we had to deal with. And on the network engineering side, we've historically focused on modeling of the network and services, et cetera. And ultimately, our hypothesis and kind of what we're pushing for today is the fact that most services are going to be distributed in nature, and most services are going to not just be within a single cloud, but they're going to traverse multiple clouds and connect out to SD-WAN and some of those other domains that we talked at the onset. So from an Untitled standpoint, it's not just important to think about any one individual or team having all these skill sets, but it's really around how do we bring the best of what we've learned within each of these domains, and how do we apply these basic principles and techniques to this multi-cloud problem. Because as we see it, historically, CIOs have been very comfortable dividing these teams into two buckets. I would have an application team that had applications in the data center, and they were supported by a network engineering team that supported the network infrastructure within that data center and my branches. And then if an application migrated to the cloud, then I would have, sometimes under the umbrella of a DevOps team, but I would have my cloud team manage that application. And, the fact of the matter is managing a VPC and a virtual interface is slightly more simple than managing an entire network. So at the time, a lot of those use cases, the networking was simple enough where it wasn't necessarily thought of that we needed as much network complexity. And, depending upon different enterprises we speak with, people are in different varying places on how comfortable they are with these separate teams. But when we start thinking about kind of modern services and what most people are talking about and kind of those macro trends we talked about at the beginning, whether people are adopting SD-WAN 2.0 as we talk about in the ONU community, or whether people are adopting multi-cloud, distributed cloud, or 5G, these services traverse multiple domains, and they really take on the techniques and capabilities brought forth by both of these teams. And we foresee the fact that the complexity of these services are no longer a simple VPC in the cloud. The networking is complex enough that we need the expertise of our networking teams. And as more things move into the cloud, we can take kind of the best of both worlds combined together to help kind of answer these problems. And we're kind of jumping all the way to the distributed cloud complexity model rather than the build-up for the purpose of time. But if people go from a single cloud, then they go to multiple clouds, and then they start consuming SaaS platforms. On here, I think we have maybe a Salesforce or ServiceNow, and then they need better service to those SaaS platforms. So they might onboard through an IXC like an Equinix, and they still have their underlay through their traditional service providers. Pretty quickly, you see that we ended up with workloads kind of all over the internet, for lack of a better term. And ultimately, each line of business is going to optimize what they're performing for the business. So if a security team feels like it's in their best interest to trunk traffic through like a Zscaler or POP, then that might help with the security posture of zero trust for the enterprise. Or if the AAA team decides they're going to move their in-house on-premise LDAP AD implementation into Azure as a service, then we're going to be trunking traffic through that. So before we know it, we're sending kind of traffic all over the place. And ultimately, the question is, how do we provide a reliable, high quality of service securely to support the business with the workloads where they see it? And from our spot, we see most enterprises adopting a large variety of these technologies, and as maybe I've said a few times, the velocity of change continues to increase. So, Mike, I don't know if you.
Yeah, absolutely. If you had shown me this diagram 5 or 10 years ago, my hair would have caught on fire, or what is left of my hair, and I would have gone running out of the room, because I would have. How do you manage this stuff, right? I mean, how do you upskill your people? How do you manage the complexity of this? And so it's a good thing you've invented something. How's that for a plug?
There you go. And I guess one other way to think about it, and one thing I usually like to talk about in the more detailed version of this, is that on this left-hand side might not be the best representation, but the idea is when we move from a data center to the cloud, if the y-axis on this is complexity, when I pulled an application and moved it from my data center to the cloud, I got this little bump on simplicity, because most people would argue that the first couple applications I put in the cloud reduces my overall complexity. And I think back to my comment about CIOs feeling comfortable splitting their teams between network engineering and kind of cloud/DevOps teams. That complexity decreased, and I actually think the level of investment in management of networks it correlates to that over the time when people were moving to a single cloud. But as we went from the single cloud to multiple clouds to adding SD-WAN plus my IXCs plus my CASBs plus my SaaS platforms, the complexity has outstretched even what we had when we had it within a single data center. So I think that we had this little hockey effect where complexity decreased in the near term, but as we kind of took cloud adoption and workload placement to an extreme, the complexity has actually increased dramatically from where we started. And ultimately, it's better for the business, but I think from how we managing the network infrastructure becomes the backbone of my digital transformation. It becomes a critical component for business execution. And I think as we all evaluate infrastructure management, obviously self-serving from our perspective, we feel like network management and automation of this distributed cloud is a key outcome for businesses to realize a lot of these benefits. So and hopefully most of this was more market facing than necessarily just talking about Untitled technology, but a lot of people do ask kind of where we sit. And from our perspective, we want to, and we really think integration with a lot of environments and a lot of controllers and orchestrators and DevOps platforms is really what you'll hear from us. Obviously, in that distributed cloud environment, for you to adopt a piece of technology to help solve that, it needs to, talk to all those things. So we're proud and talk a lot about our adapters and how we rapidly prototype those and how our end customers build them, on our dev site and all that kind of stuff. But the idea is connect to any domain, connect to all those platforms, and ultimately provide an automation platform where you can automate both today's jobs and future jobs in a low-code environment. So on the southbound side is sitting most of the networking technologies, and equally important is the integration with the rest of your enterprise IT applications, because especially in these modern network services, just configuring the network's not enough. We really look at automation as an end-to-end concept, and a majority of if we look at an interval time of when I decide I want to do something to the time that's been changed, a lot of the time is spent coordinating change, getting approvals, getting information from resource platforms, IPAM systems, order management, all that kind of stuff. So really automating the end-to-end process incorporates the variety of networking technologies, but also integrating with the rest of your enterprise platform so we can automate the entire end-to-end process, ultimately to put it in a pipeline for your application owners to have a network API independent of what technologies you choose to implement. So from that perspective, you'll hear a lot about API first from us, because ultimately, as networking technologies start to represent themselves as software and start to represent themselves as endpoints, moving more from the CLI towards an API first mentality, the platform was built to consume those APIs in a real-time way, and ultimately providing abstraction and federation is critically important. Because at the end of the day, years ago, we would have talked about this as there's going to be a handful of controllers. And now basically, whether it's a public cloud interface, an SD-WAN platform, a zero trust environment, customers feel overwhelmed by these APIs, and providing abstraction and federation provides an automation environment where you can automate independent of some of the technologies you've chosen, which we can talk about in a bit. And ultimately, we don't automate anything. We automate networks and infrastructure. So there's a set of technologies and techniques in the networking domain that if you're providing network automation are critical to understand. So the platform out of the box understands concepts like Yang, YAML, and Tosca. It consumes those models so the platform can kind of morph to that behavior. And ultimately back to kind of the combining of skills from both the DevOps practices and network engineering, it's really important to provide some low-code concepts so that we can have the most people participate in automation. Network automation really finds itself at the intersection of a lot of different skill sets and domains, and we feel like it's our responsibility to have a platform that expresses itself so that developers, DevOps personnel, and network engineers all feel comfortable in a variety of interfaces to participate in this automation. Most customers in the market tell us that we need more people helping, not less. So we find it our responsibility to have an interface that supports a variety of people participating ultimately in network automation. So we're going to do 2 demos today. The first one, single cloud, and Rich, I won't spoil the second demo that you're going to build up to. But with that, I'll turn it over to Rich to walk through a bit of how the platform supports cloud network automation.
Thanks, Chris. I appreciate it. So in this demo, or series of demos, we're going to show Untilted's ability to build network automations across both physical and cloud infrastructure. So let me share my screen out here. And so what you're looking at here, I hope, is a diagram of the demo environment we're going to be operating in. At the bottom, we have our Untitled automation platform, and we're going to be using our open source adapters for AWS, Azure, and Cisco Meraki, and use the native APIs to build infrastructure inside each one of these locations, these areas, and then ultimately connect everything back together again to illustrate the ability to do both physical and cloud infrastructures, and then be able to tie it all together again based off of whatever the needs are for that particular process, task, or network service. So the first step in this is our workflow is going to start with interfacing with AWS and creating a VPC within AWS as our first step. And so let's switch over to the Itential platform. And as you were to first log into the Itential platform, you're going to see the dashboard. And where we want to stop by first is the Automation Studio. The Automation Studio is where automations are designed and built in a low-code environment like Chris had mentioned. And on the left side here is a list of the automations that are on the platform. These automations, many of them were built by myself and my colleagues. We have pre-built automations that can be immediately imported into the platform. They're freely available on our developer website, and they would appear here. And I'm going to scroll down to the automation we'll be showing today. And this is the workflow for the automation that we'll be running in a moment. And I think it's good to take just a moment to explain what we're looking at here. Right across this area where the automation is the canvas. You'll see that for every automation, there's a start and an end point. And within there are multiple steps and tasks that are occurring. You'll notice that the purple shapes here are operations tasks that are available within the platform. This particular operations task, if I zoom in a little bit, this child job, this is an important one. This allows us to run within this particular automation, another automation. And so in this case, a colleague of mine has built an automation already previously that I'm running here as part of mine as a step to provision the AWS VPC. So our first step is actually the work of one of my colleagues that I now get to incorporate into mine, and now we can start building bigger and more important and impressive automations leveraging the work of colleagues that I have on my team in the networking side, or perhaps even cloud or other organizations. Because as Chris illustrated, we have the ability to integrate into not just networking systems and platforms, but all kinds of other platforms as well. The other purple circle here is a query. This is another operations task. This task is important because it allows us to extract data from the output of a previous task. And here's what I mean by that. In this particular task on the AWS side, we're going to create a VPC. And when you create a VPC, the APIs that create are going to spit out a lot of information about everything that was created. And we're really interested in getting the unique VPC ID because we're going to use that in later tasks. So the queries allow us to query that information out and store it and make it available for tasks later down the road. These green boxes are automation tasks. They are the API calls that are available from a particular system or platform or controller that are made available through the adapter. And remember, our adapters are the interfaces into these platforms. So when we onboard a system through an adapter, the API calls that are presented through that adapter are presented here so that we can drag them and drop them into the canvas and start using them immediately. Lastly, the blue box here is a task that requires human intervention. Now, technically, we want to see as few of these as possible because the whole point of automation is to let the machines do it. However, in this case, this is useful because it's going to give us a nice breaking point to stop and take a look at what's been done, but also think in terms of being able to do pre-checks and post-checks. What does the network state look like before we make a change? We make the change. What does it look like after the change? Compare the two and present that to a human being. We may want to do that as part of a process. So the manual intervention tasks are there. They will stop the workflow, and somebody has to manually go in and progress it through that task. You'll notice also that the green arrows are connecting these boxes. These are the success tasks, the success flow. So of a particular task, if it completes successfully, it follows the green arrows and flows to the next task or set of tasks. We also have the ability to create a flow based off of error conditions, failures, and looping. So while we're not presenting it here in a production task, you would want to build out contingent pathways. So in case something failed, what do? you want to roll it back? Do you want to show that information to a human? Do you want to log it? Something to that sort. That's what those flows are helpful for as well. Now, all of these tasks are available on the right-hand side here. In this side, these tasks can be searched, selected, and dropped on the canvas. And again, when you onboard another system into our platform, all of these tasks, all the API calls become tasks that are available to drop into the canvas. And the last thing I want to mention is, as you're building in the Automation Studio, the thing that you're not focused on is about writing code. You're focused on building the logical process as you would think it out step by step as a network engineer or some other person. You're thinking about the logical process. You're picking the right tasks from what's available on the right-hand side. You're putting them on the canvas. And then you're managing the input and the output of the task. So from create VPC, I need a VPC ID. I need to pass that on to the next task, which is attach that VPC to a gateway of some sort, and so on and so forth until the task is complete. And that's what makes this really powerful, is that we allow anybody to get into the platform, especially on the networking side, and get started with automation without having to learn a bunch of code, or no code at all, actually. So from here, I'll take us over to the automation catalog. So where the Automation Studio is where we design and build automations, we would run them and publish them and make them available in the automation catalog. And from here, we can do things like create forms. And so if I run this, you'll see that a form is presented here. These forms are definable. They allow for user input or selectability of some variables, and then those can be used in the automation. So in this case, I'm simply going to run this, and then now it started the job. And if I go over to our job manager, we can see a list of the jobs that are running on the platform right now. We see this is the one that we just started. And now we can visualize it and see step by step what's going on. So right now we started, and now it's working on that sub workflow. So that's a secondary workflow that I'm using in this system, and it's creating the AWS VPC. And you know, one thing about VPCs is by themselves they're not that useful. You actually have to have multiple things attached to a VPC to make it useful. You have to have a subnet. You have to have a routing table. Really, you need to have also, in order to get anything in and out of it on the internet, you have to have an internet gateway. And so that particular task was doing all of that on the back end. It completed. Now it's we've queried information out of it. The next part that's completed was attaching this to a VPC, because we'll be doing that, using that in a later step. And then we've paused our workflow right here with the blue task. And so what I can do now is I can go over to the details, and the whole workflow is paused so that I can work on this task. And if I click work task, it's going to show me that the information that was passed from the original task of creating the VPC, it's returned to me, hey, this is the VPC ID that we just created. I'm passing that into this, this workflow just as an informational thing to me. And if I hop over to my AWS dashboard and reload, we'll be able to see that through that, just that one section of the automation, we actually created another VPC. And just like I said, VPCs by themselves aren't very useful. You have to have subnets attached to them. You have to have route tables attached to them. And then you have to have internet gateways so that you can get traffic in and out of them. And so all of that was done in the first step of this automation. And at this point, we can pause this demo, and I'm going to pass it back to Chris for a moment, and we'll get back to this in a moment.
Awesome, thanks, Rich. When we think about integrating with these variety of systems, and as I was listening to Rich, we talk a lot about adapters. So I just want to give a little context about kind of what's happening here. So, you know, today we're talking a lot about multi-cloud networking, but the reality is that networking comes in all sorts of forms. It's always interesting to me when we talk about VPCs. I mean, ultimately these things are virtual networks, you know, attached to either virtual or physical devices. So we call them something different, but ultimately we're still talking about layer 2 and layer 3 domains, layer 7 networking. from a technology perspective, not much has changed. It's really a consumability and how we operationalize these concepts. But ultimately, from an intentional standpoint, we want to talk to a whole lot of things, and we've talked about adapters. And I don't want it to be lost on anybody that, you need a variety of techniques and tools to inflict your change in a variety of domains. So from a networking standpoint, we really see kind of four main groupings of these. Today, we're starting all the way on the left with cloud orchestrators. I debate it often with folks about the fact that even public cloud interfaces, they're a set of orchestrators. Those that look at Kubernetes and OpenStack and private cloud technologies. They're not the same technologies underpinning some of the cloud providers, but ultimately they are orchestrators that provide a set of APIs. Each region or zone might implement the exact same APIs, but they don't know about each other. So if I have 10 zones, just like I might have 10 Ansible engines, just like I might have 10 different network orchestration tools, I still have to be able to talk to all those. And part of what Itential provides kind of behind the scenes out of the box that we're not demonstrating today is the concept that when we talk to things, we discover what's there. So we discover what Yang models exist, we discover what APIs are available, and we create a routing layer internal so that when Rich is dragging it on the canvas and he wants to make a change to a VPC, we keep track of kind of like which implementation of that orchestration layer houses that VPC. So there is, I think, some important concepts as we start to scale network automation that are very important to keep the simplicity or keep the complexity away from the end users, the application owners. They shouldn't necessarily understand which model of router we pick. They shouldn't necessarily know which zone their workload's running in. They just want to inflict the change to support their application. But ultimately, in its most robust, it could be a cloud orchestrator. There's a whole host of network orchestration tools fall into the bucket of SD-WAN, data center overlay, et cetera. But we also have, DevOps tools have really stepped in as kind of innovation on top of a lot of the CLI concepts. So, as we move more towards APIs, we can't exclude the majority of devices deployed today are still CLI dominant, I would say. But we have a whole host of tools to make them, quote unquote, more programmable and more standardized. So that we really onboard those DevOps tools with native integrations with things like Ansible and Terraform. And ultimately, teams already have all sorts of scripts and things they've written. So from an Itential standpoint, we don't want people to feel like they have to completely start over to onboard automation. So the idea is bring what you got. So sometimes that's scripts, sometimes it's some Ansible playbooks, sometimes people have adopted an SD-WAN platform. And the question is, how can we take what you have, build the most robust automation possible with that given technology and bring it together in a holistic automation strategy. And then over time, if you choose to, you could say, hey, you know what, that script that changes passwords or roles host names or make sure all my interface descriptions are standard, maybe I re-implement that script in one of the more modern tool chains. But ultimately, the idea is you shouldn't have to go backwards to, you shouldn't have to take 2 steps back to go 1 step forward. You should be able to start with what you got and make progress. So it's just really important from our perspective that we can talk to a variety of systems. We can talk the native language of those systems, whether it's YAML, Yang, Tosca, JSON, et cetera. And ultimately, we're moving beyond the idea of just API integration, and we're really, as an industry, moving towards data integration. Because ultimately, as you see with the demonstration today and more robust demonstrations, when you start adding ticketing systems, resource management, it's really, how do I take the data out of an order system or an ITSM system? How do I morph the data? Because the return data from AWS does not come in a format that's ready to go into my IPAM system to request a resource. I have to manipulate that data. So the question is, how do we can do data integration to really remove the burden from network engineering and operations teams? I think as an industry, we've done a great job with APIs, and we're really moving from kind of that API integration standardization around open API specification and really around JSON schema more towards a data integration layer to continue to increase the velocity and speed of change within the network. So with that said, I'll hand it back over to Rich to add in the other components of the demo.
Thanks, Chris. All right. So where we left off was step one, building out the AWS VPC. Now, as we continue on to the next stage of the same demo, we're going to focus our attention to an on-prem site. This is actually the Atlanta office for Untitled, where we'll do some configurations on a physical device, a Meraki appliance, using API calls through the Meraki controller. The whole point here is that we bring up a site-to-site VPN, so doing the configuration on the on-prem site, doing the configuration in AWS, bringing up a VPN gateway and a site-to-site VPN so that we can build connectivity that allows us to, from a host in AWS on the 10.50.00 subnet, be able to reach a host in the Atlanta office on the 172.20.100.0 subnet. So where we left off was here. We paused our workflow. We're back into the job manager. The workflow is just sitting here waiting for us. If I click continue and we go back and visualize the automation, it started here. It's doing some work on the AWS side, working through the Meraki side of the VPN, and then it's come to another pause point for us so that we can stop there and go back to our diagram here. So now that piece of it's done. We configured AWS initially with the VPC, which was necessary in order for us to create the other networking constructs just to get to the point to have the AWS side ready for a site-to-site VPN. We did some work on a physical on-prem device to instantiate its side of the VPN, and now that piece is up. Now we're going to focus our attention onto the Azure side. And we're going to do something very similar here. So the last part of this demo is we need to use API calls through the automation platform, through our adapters, to create the network services on the Azure side to bring up its side of the VPN here. And so similarly, we want to make sure we can have connectivity from the AWS hosts at 10.50.0.0 all the way through the site-to-site VPN to the Azure hosts, which are at 10.60.0.0. And so all we really need to do now is go back to our job manager. Again, this is where we stopped at because of the intervention task. If I work the task, it's going to tell me, hey, the VPN call to Meraki was succeeded. Here is your new VPN ID. That was data that was captured from the output of AWS. If I click continue here, and then we can go back to visualize, and then we can see it finishing this out. So it's doing something similar on the AWS side to create its piece of the VPN configuration, creating the Azure side. And then finally, the last part of this is pushing some rules, updating the routing table on AWS. If I go back to our diagram here, so what we've done now that that's completed is we've created a site-to-site VPN on this side. We've made sure for this VPN that there's IP connectivity between AWS and the Atlanta side. We've just finished the automation that completes this side of it so that Azure and AWS devices can speak to each other. However, we also want to do one thing, and this is update the AWS routing table so that it can act as a transit between the two. So that gives us connectivity from the hosts in Azure at 10.60.0.0 all the way through the VPC, through all of the native cloud networking, through that acting as a transit or router, and over to the Atlanta office. So the first step in testing that would be, let's see if we can hit a ping through there. And so what I've done is on this, we're going to start on this host right here, 10.50.0.85 in AWS, this orange line here. I've already got it primed to ping this host at 172.20.100.44. So we're going to verify our connectivity there. So that's over the site-to-site VPN that we've created in step one. Our next step in testing connectivity is to see if we can use, again, on this host, 10.50.0.85, and let's see if we can ping a device in Azure at 10.60.0.4. So I've got it primed here. And now that's going. And then the final test for this is, do we have connectivity through AWS, completing kind of this whole on-prem to cloud infrastructure demonstration. by using a host in Azure at 10.60.04, pinging through AWS, and then back to on-prem to a host at 172.20.100.44. And success. So before I turn it back over to Chris, let me just recap what we just accomplished. Using the iTentral automation platform, we created an automation workflow that can provision end-to-end network infrastructure using both physical devices, Meraki, and multiple cloud native networking services, both in AWS and in Azure. And we were able to do this in a low-code environment, which really makes it easy and accessible for network engineers or really anybody in an organization that has systems that need to be integrated with. And so we hope you can see the value in how we provide this, but also that whether it's on-prem, whether it's cloud networking, our integrations work, our workflows work similarly, and that it's important going into this new world of hybrid cloud, multi-cloud, that these types of automation technologies exist and are readily and easily available for everybody in the organization. And with that, I'll hand it back over to you, Chris.
So we just wanted to wrap up here, just talking a little bit about hopefully what you saw today. The one thing of interest that we didn't really talk about too much is that the adapters to these systems, I think Rich used the word open source at one point, both the adapters and the pre-builts, like the child workflow that he ran within that automation is posted on GitLab, and it's referenced on our developer site. So if there's interest between anybody on the call that's, you know, what adapters exist and what pre-built automations exist, they're updated all the time on the GitLab repo, and then it's referenced within the developer site. So at developer.itentral.io, we keep that updated. So that's where you can see more. There's also, you know, the automation engine. We really focused on the automation studio today. There's all sorts of config and policy management stuff, which from time's sake perspective, we tried to focus on the topic at hand. But if we think about the use cases that are most appropriate, I think in the chat window, somebody had asked kind of what are the top use cases. It's interesting that a lot of these use cases, the same words are used for on-prem. So, you know, when we talk about golden config and compliance, you know, traditionally that's been, you know, does a set of regular expression matches and CLI text match what's on the box? The same could be true for a VPC, because we're managing the lifecycle of application deployments, but there's certain parts of the VPC that most enterprises say, I always want to be there. So the application of kind of what are the most appropriate use cases, it's almost a mirror of the types of cases that we have in almost traditional on-prem networking. So it's still load balancing, VIPs, DNS, routes, subnet masks, security concepts. And then we have obviously some new concepts with transits and integrating with SD-WAN overlay concepts. So hopefully everybody found today's discussion useful, and Michael will see if there's any questions from the audience or if you have any yourself.
Absolutely. Thanks so much, Rich and Chris. Wow, I think I could go for another hour on this subject, maybe in the rest of the afternoon even. So from our friend Ted Turner, we have the question, what CMDB can be integrated with iTentral to help understand the structures when issues arise? That is, when you need to call a vendor for support, remedial impact or immediate impact, I think that means. Is there a system of record where iTentral components instantiated are stored?
Yeah, so kind of core to the, we have this concept of federated source of truth, and you know, Ted, I'm not sure where you fit on the spectrum, but you know, we see this journey where historically we tried to take copies of everything and put it in a big CMDB. You know, historically maybe like a Remedy, and more modern like in a ServiceNow. And what we're seeing, you know, and Michael led on with some of the container-focused stuff and Kubernetes stuff, even with SD-WAN and some of the self-serve portals for end customers, the velocity of change is such that it's almost unreasonable. I mean, to keep the state of all virtual concepts in CMDB. And I'm not saying that's what you're suggesting, but it's really like what stays in CMDB continues to shrink. So I would say almost all deployments of iTential have some integration with the CMDB of choice for change management concepts, for device asset type of integration. So that's a very, very typical thing. And iTential tries to be the source of truth for the fewest things possible, which might sound a little odd, but we believe that the natural state of things is that the sources of truth need to be in the place where they make the most sense. So if I want to understand what the state of my VPC is, it's probably best to go ask Amazon right now. If I want to understand what the state of my SD-WAN overlay circuit is, I probably need to go ask my controller right now. Now, I need to understand assets and physical devices and where to go get the information. But we do think the world's moving towards more of a real-time API accessibility. I probably went on past the question, but almost all deployments include integration with CMDB, and we would update the CMDB on any of our actions, representing the CMDB as the source of truth rather than us. Because just from like a guiding principle standpoint, we don't think we should keep copies of data because we think that leads to problems over time.
Okay, thank you. We're running just a bit shy on time, so let me move through these next few quickly, Chris.
Sure.
Could you use another one from Mr. Use Case Ramesh, could you use the transit gateway instead of the VPG gateway?
Yes, and I think there's actually a transit gateway pre-built automation out there, Rich, or maybe it's still in the process of being posted. The nature of supporting VPCs and VNets today just happens to be because that's what the team focused on the set of APIs. Any of the services that are provided by public cloud providers can have an adapter built and then a pre-built wrapped around it. So there's nothing in the system doesn't inherently know anything about a VPC more than it's a set of API calls that represents a networking construct that was built into the pre-built automation. So I believe today we have adapters and pre-built for VPCs, VNets, and transit gateways, but we're always working on that list, and that's why we decided to put it on the developer site. So hopefully we can transparently publish and keep everybody up to speed on what exists.
Great. Okay. More stuff coming in. We've got two from Hiram. First one, so I'll read this as a two-part and repeat it if you need me to. Do you currently work with any of the overlay solutions in the cloud, or is this cloud native only? Part one. And part two, how can I try out your solution?
Yeah, so I'll take the overlay solution versus the cloud native. So much like we would work with a physical device or we would work with an SD-WAN controller, we just view an overlay, and I'll take that as like one of the tools branded as multi-cloud. That's really a controller in the cloud that's abstracting some of the underlying transit, VPC, VNet types of questions. So we would integrate with that controller rather than directly with the VPC. So we're very comfortable dealing with the lowest level networking construct or working through one of those controllers or orchestrators. So we definitely will have adapters for those controllers, and we can request that those network constructs be implemented on our behalf, or we could go directly to the native constructs of the cloud providers and provide them. And ultimately, we just want to provide the toolkit so the customer can ultimately decide whether they want to use kind of the native interface or they want to work through a controller or orchestrator of choice. And it kind of comes back to, in our opinion, coming back to the kind of the tools and techniques that are most appropriate for that domain. And then where can they try out the software? There is an iTential 101. It spins up a little Docker image, has video lessons with it that everybody can sign up for. And we continue to innovate on how we can put the technology in people's hands as easy as possible. So,
you know, I've been meaning to spin that up, and now I'm going to do it right after this. I'm feeling inspired. So I'll give you a review, Chris, but not a public one. Okay, so we have 5 minutes left or less. We have one question. Can you explain the integration with Ansible and iTential?
Sure, or you can also reach out to me. I'm happy to talk about it. So when we look at integrating with any of these networking tools, the goal is to maximize the leverage of that technology, because obviously if a customer is using that, then we want to maximally use that. So in the case of Ansible, we integrate, and I think we have webinars and documentation on this as well on the developer site. So feel free to go check it out. But Ansible describes their capabilities in a set of modules, roles, playbooks, collections, and ultimately through a set of flows that can be described within Ansible Tower. So from our perspective, we integrate with each of those layers so that customers can use anything they've already built, or they can use some of the low-level native constructs. So if people want to call a module directly, what Rich showed you on that page is you can get to you can go to the Ansible modules, drop it down, and any module that's existing within Ansible will be auto-discovered and auto-rendered. You can also register networking roles, which is not speaking for Red Hat, but is some of the abstractions they built on top of their modules, which I find quite powerful. And then if customers have built playbooks, we can execute those straight out. And if people have coordinated those playbooks within a Tower job, I think it's called, we also have an adapter on the developer site to Ansible Tower so they can instrument those. So kind of how we think about it is we want to provide integration at all of the layers that those types of providers expose, so that customers can look at iTential as a power user of those tools and does not restrict their usage in any way. So that applies to data center overlay, it applies to SD-WAN controllers, it applies to the public cloud providers. At the end of the day, these are a set of technologies that customers are trying to adopt, and we want to allow them to maximally use anything they've already developed.
All right. Chris, if you wouldn't mind moving to the next slide, I'll wrap this up. So thanks very much again to Chris Wade and Rich Martin from iTential for, I think, a really stimulating hour, bringing us all up to date on the state of network automation, as it's not only been imagined, if you will, but realized by iTential. Hope you all go out and check out the iTential 101 demo like I'm going to. And thank you, Chris and Rich, and thanks to our audience for sitting with us throughout the hour. Finally, just a brief note that we will be holding ONUG Fall 2020 this October 14th and 15th, initially planned for New York City, as it historically is always run in New York in the fall. But as we did with the spring ONUG iteration, quite likely that this one will have a strong virtual component as well. Planning is underway, but for those of you who went to ONUG Digital Live, ODL, this spring, you'll know that we ran a very, very full and active 2-day conference that had a great deal of interactivity, and frankly, I think it was it really kind of turned our heads about what you can do with a virtual conference. We had, in some respects, more engagement between participants and registrants and speakers than we typically do even at a live conference. It's different. So we will see what the fall brings us, but you can count on there being ONUG Fall 2020 this October 14th and 15th. So please go to onug.net. Get yourselves registered if that seems like the thing to do. I think it is. And we'll hope to see iTential there, and hope to see some more advances in the world of network automation, as well as all the other wonders that we try to bring to all of you in our community at ONUG. So thanks all, and we'll see you next time.
Thanks, everyone.
Thank you.